straight away. If the presenters could come to the stage.
Hello, good morning. Since we're a bit behind schedule, we're going to start right away with Jan speaking about the web whirlwind.
Thank you. Good morning. It's going to be difficult to follow this very, very nice keynote, very interesting. Here to give you an update on the Web Whirlwind project, what we've done since the last FOSS4GE Europe in Paris, and what couple of topics we still want to tackle before calling it 1.0. I work for Solenix, and I lead the European team contributing to Whirlwind. We call it ESA, NASA Web Whirlwind, because those are the two main sponsors of the project, but this presentation is my view of what's happening, not an official statement from any of those agencies. For those of you who don't know Web Whirlwind, this is a virtual globe. It has a long history, has been around as a project for many, many years, starting with .NET, then going into Java, iOS, Android, and for a couple of years now we're focusing on the web port of the SDK. HTML5, JavaScript API. What's important to note about Whirlwind is this is not an application. It's not like a Google Earth that you will open your desktop or web page and start working or playing with. It's the building blocks. It's a rich collection of features that allows you to build your own application, your own tailored application, your own web pages in that case. Okay, so this is an example on your right side of a representation with not much data, but of the concept of a virtual globe. Throughout the presentation, I will use some terms. So I wanted to give you an overview of what's inside, so you can relate to the different parts I will mention. You as an app developer are on the left, and you're interacting with the components that are blue here. Starting with the world window, this is the definition of the visual aspect of the drawing, handling the OpenGL, WebGL part in that case, and doing the actual rendering. Of a globe, which is the definition of what you're rendering, basically the structure, the ellipsoid here, which can have an elevation model with its terrain loaded from the web external sources. On top, you will put layers that are wrapped around the globe, but also layers that can interact with all the space around this system. Can be imagery, can be other elements like shapes, surface shapes around 3D buildings, models in space, etc. And finally, you have a notion of navigator, which is where the camera is, what you're looking at, how you're moving around the 3D environment. Notion that's not here, but important for the presentation, are controllers. Those are the elements you use. We provide some. You can write your own to intercept user events, gestures, and act on the 3D environment. Okay, so that's, in a nutshell, a virtual globe, the overall, the key components, what you're playing with, which is relatively standard as a stack. I mean, you define where you are, you put stuff on top of it to create visualizations. So what's new or newish, because we're talking news from up to a year ago. In the past year, we've merged about 200 pull requests with enhancement in a broad scope of features, from file formats, precision with the mass behind the globe, some improvement in how we use the GPU. We've made some fixing for typically text speaking. We've also migrated the whole default stack to HTTPS, made some correction in WMTS. So plenty of small enhancements have been made in the past year. In more new features type of novelties, we have two new data format, well-known text as the definition of shapes, not as a definition of the reference, coordinate reference system. And the ASCII grids for elevation data in some cases. We also started with exporters, so going from, for example, if you have a user draw something on the globe and then you want to get that definition into a standard format, we call them exporters. We have GeoJSON and well-known text at the moment. And coming very soon, and that's what I'm going to discuss a bit more, are changes to the way we handle elevation around the globe. A shape editor creator that I had mentioned a year ago but has changed quite a lot in the meantime, heatmap layer, and support from rendering responses from OpenSearch4EU. So in the past year, we also made the first numbered release of the project. I said it's pretty old, couple of years old, but we had never actually put a version number to a state of the project. It's the first one. We call it .9. I'm not sure I've mentioned that already to this community. We called it .9 because we wanted to reflect the fact that it's actually already pretty stable. It's not like it's an alpha that is going to break. It's used in plenty of production systems. But we're not ready yet to commit to the stability of the API too much. The release is available on GitHub. We also made, that's also a recent 7-8 months ago change, to make the module compatible with NPM, a true JavaScript module, and not just an independent library. So you can get it from NPM, you can get it from a content distribution network hosted by NASA Ames. And what was interesting in this process of releasing this first version is that we had to figure out how to do the testing. There is a lot you can automate, of course, all the mass behind the globe, but it's a lot about rendering and what you see and how the user interact with the globe. And there are tools, yes, to automate that. You can think about a Selenium or other systems that can automate your browser, but we decided that still quite some of the testing needed to be done manually at this stage. So this is an experience. If people have other experiences with automating or testing this kind of very visual piece of software, I'm happy to discuss it. What we've done is we've created 44 scenarios that are covering the main features of the framework, and we had 10 persons testing that in 15 browser operating system combination manually. So it's quite an investment. Not everybody tested the 15 combinations. Okay, they were split among the testers, and that's how we went at ensuring we were releasing something stable, good, and that could be used in production application with a good degree of confidence. What does this? So what's right around the corner? Originally, WorldWind has one elevation model per globe. So you define your globe and the ellipsoid, and then you add elevation on it, and you could define one global elevation model per globe. That's it. Which meant if you wanted to do something high resolution, you need to do something high resolution for the entire globe. And for that, we are offering some models, a default one called Earth elevation model that was using data from NASA, a zero elevation model that was just offering, which is basically zero, just the ellipsoid, and then two others with REST and WCS to load some data in different formats. And what we wanted to do is refactor all of that to allow for local high resolution coverages. So if you have a model of a city or of a region that is high resolution, that you could easily include that, load this particular data set when it's needed, at the resolution it's needed for particular regions. So at the end, it's still one global elevation model per globe, but this elevation model, the default one we provide, you can still replace it if you want. But the one we provide contains different coverages, and those coverages are actually the actual definition of data, the actual data source behind. And they can be of any size. They can be global, regional, local, whatever. There is no limits. And then the coverages we offer now are basically the same that you had the elevations model before. You can still load your data through WMS, WCS, some kind of level row column protocol. And there are specific implementations of those coverages for the default sources we have. On top of that, we're adding more format. There's GeoTIFF, there is this BIL16 binary format, and now this ASCII grid is being integrated. So the idea is more flexibility. It's very useful in particular for like urban applications to be able to have those very high resolution models very locally, but still the entire globe around. Shape editor. At the moment it's only, so we differentiate editor and creator. This is going to be implemented with the same component, but the user interactions are slightly different if you're creating something entirely new on the globe or if you're modifying an existing piece. Yeah. At the moment it's only for surface shapes, and we'll come to air shapes, implementing air shapes first and then their edition. So all of them, circular ellipses, but not the images. We're very keen on supporting mobile devices. That's actually where my group is using it most. So it's mouse and touch gesture compatible. Just an example here. Since the first iterations on this shape editor, we've simplified a lot the API, and I wanted to show a tiny bit of code to explain how easy it will be. You basically, how to edit, you basically need a reference somewhere to your shape, which can be because you've created it purely by code programmatically, or you had your user pick it on the globe directly, or you have loaded it from a GA or JSON file. You need a pointer, a reference to that. And then you create your shape editor that you attach to World Window. World Window is multi-windows, and you can also have multiple globes on the same page. So you need to attach the editor so it knows on what to act. And then you simply say edit, and you pass your reference to the shape. This will enable all the logic, all the control points to edit the vertex, to resize the shape, etc. And then when your user is done, you can call stop to terminate the edition. And then in how to create, you see something, it's direction we're taking in general in the framework. We've been using a lot of callbacks originally, and we're moving to promises in all the new interfaces we're doing. The idea here is when you create, there is a moment where you don't have a valid shape. If you imagine a polygon, for example, you click the first point somewhere on the globe, you click the second point, you have a line, you still don't have a polygon, then you click a third point, you actually have a polygon at this stage. So there is this unknown step that you can consider asynchronous, and the promise will complete when the shape is actually available. Another decision we've made here is that we render while drawing the shape, but then it's up to you to do something with it once the creation is done, because somebody might not want to draw the shape on the globe. Somebody might want to then use an exporter in well-known text to send a query to a server, for example, what has been drawn. Here I'm simply adding it to the globe so it stays visible, but you could do other things. So that's how the shape editor will work. That's to show the new direction also in the APIs, getting them simpler and simpler. Heat map, that was just to show, because I like this image, it looks like the Earth has chicken pox. It's It's pretty easy. It's a new layer. You just give an array of measured locations, concept that is well known also to shapefiles, and even GeoJSON as that, well-known text as that. You can assign some kind of a measure to a point, and you can give this information to the layer. It works relatively large scale. It's fully customizable. So it's one of the new additions. So that's in a nutshell some of the few things we've done. And the question we might ask, okay, why are they not releasing it now as a 1.0 if they're so confident that it's stable and well tested and so on and so forth? What we wrote with the last release is the statement that's above. And it's clear to me, at least, that there will be adjustments. Okay, there will be adjustments to the API. And we're going to do that progressively. We are aiming, I wanted actually to come here with the .10 out, but there are some changes in project management on the NASA side. And we've been asked until this handover is done to postpone the actual release. So we're going to go progressively. We're going to make those adjustments to the API. And a few, let's say, important points there are related to the navigator. At the moment in Whirlwind, you have to look at something. Your camera has to look at a known position. And that's quite a limitation. You define a point, it can be at an altitude, you're at a distance from it, and you look at it, okay? And then you have some limited movement of the camera at this, around this point you're looking at. For example, with that, you cannot look at the sky. If you have, for example, a plane or satellite, and you have the globe, an object in space, you cannot put your camera underneath and look up. And that's what this other navigation mode, the camera, will allow, where you actually position the camera somewhere in the space at the latitude, longitude, altitude, and then you have really on all axes, you can work your camera in any position. This also allows things like type of third-person view or flying through a valley or things like this. So this will come. It's also an ongoing work. Then, if you work with typically OGC services and their corresponding layers in Whirlwind, you've encountered this kind of very repetitive code where you have to actually get the capabilities. So you need to write the whole logic, the AJAX request to actually get the capabilities from the server. Then we provided a way to parse them, understand the capabilities, extract what you wanted, like a layer in a WMS capabilities set. And then from those capabilities, you had something to create a configuration that could be used by the layer. It's a huge series of steps, and you're always doing the same steps. Or you're creating for your application some component that has that and that you can reuse to make your life easier. So the idea is to simplify all of this quite drastically, and again, to move from this more callback function logic to promises. And you see here an example that doesn't exist yet. It's more pseudocode. Where you create a service by giving the address of your capabilities, and then you get a promise, and that gives the service the time to create itself by negotiating possibly versions, formats, whatever. And when the promise completes, you get the service. You get some flexible way of extracting directly the configuration that the layer can use from this service. Okay. And then the rest is very similar. This also solves all the question of how do you handle errors. We had throughout the framework different ways of handling errors. And with this approach, for everything that's asynchronous, you get the catch case of the promise. That will really streamline the way you use services, the way you use data formats, and so on. But then you still have people who know exactly what they want, okay? Here you have the whole flexibility of when you get your service, maybe creating some kind of view, dialog, window, whatever for having a list of layers that you can select, enable, disable, whatever. But you have people, they want just to build the globe and have a base layer on it, and that's it. And for those type of use cases, we're considering some factory pattern to try to have some kind of one call creation of layers. Boom, I want a layer. Here's the capability, here's the name, and just put that on the globe, and that's it. We're doing something similar with data formats, parsers. And in addition there, we also need to unify the API. It started with shapefile, and we've added GeoJSON and others, and they've kept the same, mostly the same logics, but not all of them. And here you see 3 examples. Let's say the GeoJSON parser is the one that looks the most like all the others. And then you have Collada that does some weird stuff with init, and there's this init step. And you have KML that is promise-based. So we're working in unifying and simplifying that, and this will look very much like what you've seen for the layers, where you have your format, you parse a file, you can give some options that are specific to the file format, and then you have a promise, and when we're done building whatever is necessary in the backend to render to the core, not the server side, in the core of the framework to render, then you will get this object that is renderable. And at the bottom, and here I'm just showing then the exporters, how they work. They would come from the format you could parse or you could export. Same thing, you might just want to put a GeoJSON file on the globe without too much thought. We're also considering one call creation of layers here. Another thing we're considering is this could include auto-detection of the format, because the web server is supposed to tell you what's the MIME type of the file it's sending you back. So we could also select the right parser. Yes, I'm almost done. Okay, we had some questions of how can we contribute, how can we help. That's something that was a bit mentioned in the keynote this morning. This is very strongly led by the NASA and ESA teams, and they're big enterprise, big here international or governmental agencies. So we have relatively strict processes on what we can accept and not in the code base. And this is changing nowadays. But we're very happy to get feedback. So if you encounter any issues using the framework, raise them on GitHub. If you have any ideas of new features that would help you, send feature requests. And we've moved entirely everything we're doing on GitHub, also the issues and the tasks of the team. So you can have a view of the ongoing development. And if you think you see something now, we're working on this elevation API stuff. If you have a use case, you're wondering if it will be supported or you would like us to take it into consideration, the GitHub issues are now the place to go and comment on those ongoing developments. Of course, you can always contribute with documentation, examples, tutorials, applications. Here I just wanted to mention the Whirlwind Labs, which is another GitHub organization that's not so tightly under the NASA ESA control, where people are putting Whirlwind-based applications and additional extensions and so on, sharing with the community. And I also wanted to show this workshop demo here that Zach, one of the developers, prepared for a one-day workshop in Washington. You have an extract on the right of the lessons that are in there, and I think it's really awesome to get started. Very finally, here I wanted to mention something that's happening this summer. Some of you may know the Europe-IA Challenge that has happened in the past couple of years around Whirlwind, where the idea is teams submit IDs, project IDs, and then they're evaluated and they're invited somewhere for a kind of final event. It's judged by a pool of international experts. This year the theme is utilize satellite data for world peace, health, education, and sustainable Earth. You don't have to answer all those questions at once, but you can pick one. The criteria, and I think this is not a problem here, it has to be open source, so all the code you're producing for the challenge. The deadline is 3rd of August, so it's in a couple of weeks. If you have an ID, cool small application, something that could be helpful, you want to prototype, by the 3rd of August you don't need a complete application. You need an ID and you need a bit of code that shows that you are able to implement this ID somehow. And the best projects will be selected for a trip to Helsinki. There are cash prizes. There is an event at the, I think this year is going to be at the Nokia Executive Center in Helsinki. So I invite you to check this, this challenge. It's a place to go this summer for free. Thank you.
We'll have a time for very, very quick question if anybody wants to ask. Go ahead. So the question was, if you have your own terrain data, how can you use that?
So you need it in one of the formats we support that I mentioned. But then from that point, there are a couple of protocols that are supported. You've seen WCS or this level column row. At the end, you have the globe that has a model, and this elevation model, and this elevation model has add coverage method. And then from there, there is a definition of how to point to your data. The API documentation, and pretty sure there is a tutorial about that in the address at the bottom here.
Okay. Thank you very much. Thank you. And up next is Astrid with MapBender.